Okay, in this video, I'll be covering the last practical skills that you need to learn before you take part in the O-level physics practical exam. Now, so far, we have not offered you the opportunity to try the actual exam format for physics practical because it is a very long paper. Now, we have covered tabling, how you present the data, how you record the data. We have covered graphing, how do you plot a proper graph, what are the elements that you should present in your graph, how you should exercise your precision rule when you calculate gradient, and finally, how do you apply the gradient to find certain constant. But there's one part of practical that we have not covered, and that is planning. In some school, they call it the design experiment. So this document that I'm showing you is actually from the SEAB, Singapore Examination Assessment Board, and basically it will cover what are the elements in the practical exam. So if you scroll down, you can actually access this document by Googling SEAB Physics. You'll be able to find this. Now this is the weighting for your different parts of your paper. So paper 1 MCQ, paper 2 your free response question covers about 80%. But actually practical covers about 20%. And it is a huge percentage. If you are aiming for an A, then you need to aim to do well in your practical. The reason behind this is because out of all the O-level paper, the physics practical paper is the only paper whereby we are very sure about what question they ask you. No, we are not saying what type of question. We are not saying what type. We are saying what question. We know exactly the question that they are asking you. They are going to ask you plot a table. They are going to ask you plot a graph. They are going to ask you find gradient. And they are going to ask you design an experiment. So we know exactly what they are asking you to do. So because of that, it presents to you a good opportunity to do well in your practical. Yeah, because we know what they are asking for, so you can prepare for this. The question now is whether you want to prepare or not. Now let's take a look at practical. What is the format like? And if you scroll down to this document, you can see it over here. So let me take a picture and so that I can write on this. Now this is the practical paper. It is super long, almost 2 hours. This is also the reason why we cannot offer you the full practical paper in your secondary 3 exams. It's simply too long. Now it consists of 2 sessions. So this paper has 2 sessions, session A and session B. Now unlike your other sciences, right, when you go into the lab, you will be asked to sit like this. So this is a bench. So let me draw out the setting. So this is like the bench. Then this is the sink. This is another bench. This is the sink. Of course, there will be the walkway over here. So let me try to move it a little bit. Then of course the teacher's bench will be in front. Now what happens is that you will sit over here and you will sit over here. You guys will be seated like this. Now what happens is that this area that is given to you only have the apparatus for section A, and your benchmate, this red color area, will only have the apparatus for section B. And same thing for here and here. This means that when the paper starts, after 55 minutes has passed, the teacher over here will give the instruction switch over. And what you will do is that you will tidy up your apparatus on section A and section B. And what happened to you is that you will move over to here and your benchmate will move over to your place. And after that, the command of start will be given again, and you will be given another 55 minutes to finish the other session. This means that after the first 55 minutes, when you are asked to leave your side of the bench and go to the other side, you will no longer have access to the apparatus for section A. So it is very important for you to actually obtain as many data as you have before you move to the other side. Because once you obtain the experimental data, even you cannot finish the question, when you reach section B or when you reach the other setup, you can try to speed yourself up, and and for whatever remaining time you manage to obtain, you can then work on the process data, you can work on the graph, and so on and so forth. So basically, physics exam format is like that. There will be this swap over mechanism whereby you will move from one seat to another, and then your benchmate will take over your apparatus. And once you have switched over, you cannot return back. You cannot say that, oh, okay, you asked me to switch over, right? So I switch over now. Oh, I'm a very good boy. I switch over. Oh, okay, we have switched over. Then you do at the 40th minute, you finish doing what you want. Can you ask the teacher, hello, can I move back here because I want to obtain more experimental data? The answer is cannot. You can't do that. Okay, so that is the unique part of the physics exam. Now, another unique feature is that the different sessions, right, will test you on different thing. It's very specific. So I will start off with something easy first. Your session B, right, is so far what you have been exposed to. It is the standard follow the instructions, set up, obtain data, record it in a table, plot a graph, find the gradient, give me the source of error. So section B is your standard practical that you have been exposed to in set 3. Now section A is the new thing. So section A consists of either one or two questions. Okay, and out of this in one of these two questions, right, the planning question will be included as part of the question. So let me show you how does it look like here. So this is the 2021 paper. This is your paper 3. As you can see, there are two sessions. So session A, and then if you scroll, section B. And if you look at this paper, right, your section A contains two questions. So section A, question 1, and section A, question 2. Okay, the planning part of the question, usually it is in question 2. So question 2, if you scroll down, you can see this huge scary blank. This is your planning question. A student claim blah 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 blah, plan an experiment, and in your plan you should include this. But look at this, they give you 3 bullet points to include. They give you almost a page of blank lines to fill. And in O-level physics, you know that the number of lines represent how much detail that you should contain. And look at the marks, 6 marks. Do you think by writing 6 lines you can get 6 marks? No. So actually this design experiment is a very elaborated set of instructions that you need to come up with to actually investigate whatever objective that they want. So in this video, what I will be doing is that I will be sharing with you a template on how to properly organize your thoughts so that you can outline detailed instruction on how this experiment should be carried out. Now, while you are writing these instructions for your experiment, you have to imagine that your target audience is stupid. Okay? Don't just say find average. Tell him take T1 plus T2 divided by 2. That is the standard of intelligence of the reader when you are writing the instruction. Don't tell them that please get accurate reading. Write down in your instruction when you want to start the stopwatch, when you want to stop the stopwatch, and tell them use what equipment are you using. If not, they will start using a pendulum, or they will start counting 1,000, 2,000, 3,000. So always state the equipment that you want to use. Now with that in mind, I hope now you understand the importance of this video. So I'll be using this video to share with you. Okay, I will run through with you how to go about doing the design part of the practical exam.